In this video, I want to talk about the idea of, in some sense, multiplying two sets. So we call this the Cartesian product. And what it is, if you have two sets, A and B, and they have to be non-empty. If they're empty, we can see down here, if anything is empty, then the Cartesian product is empty. But what it is, and this is key, it's ordered pairs. It's the set of all ordered pairs where your first element is from A and your second element is from B. And note we're using these round brackets here. The round brackets indicate that the order matters. So it's different than the curly brackets of sets. So this means order doesn't matter. Order matters when you have round brackets. And I do want to note as well, I'll just make a little note here, it's the same notation as intervals, but hopefully in the context of the problem, you can tell whether they're talking about an interval or about an ordered pair, or in general, an ordered n-tuple if you have n things together. So I do want to make the note, so intervals and ordered pairs have the same notation. I should say open intervals and ordered pairs have same notation. So be careful. Just make sure you understand which the problem is meaning. Again, in mathematics, we reuse lots of symbols because there's way more ideas than there are symbols. Okay. Remember, this is an ordered pair, so the order matters. AB isn't the same thing as BA. They're two different things. Okay, so we talked about the first point here. The sets need to be non-empty to have a non-empty Cartesian product. And you can say something about the number of elements in a Cartesian product. You can say that as long as the sets aren't infinite, as long as they have a finite number of elements inside them, that the cardinality is finite, then the cardinality of the Cartesian product is just the product of the cardinalities of each sets. And the one we're most familiar with is the idea of the Cartesian plane. So your xy coordinates in the Cartesian plane, that's a Cartesian product of two copies of R. Because remember, let me draw this out. R squared, well, what is that? That's all pairs x and y such that x is an element of R and y is an element of R. Oh, this should be a curly bracket, actually. And that's the most familiar one that people have seen. But you can do this with any sets. So let's take a look at an example. Let's look at if A is 1, 3, and B is 1, 3, 9, 11. Then A cross B, well, you can think of it as a little table, actually. Sometimes when I'm just starting out, I like to think of it as a little table. So we'll put the elements from A down the side of the columns. So this will be 1 and 3. So here's A. And then B will go across, and we'll put 1, 3, 9, 11. So you can see there are 8 cells in this little diagram here. 1, 2, 3, 4, 5, 6, 7, 8, which is unsurprising. It's 2 times 4. So there's going to be 8 elements in our Cartesian product. And these elements are going to be corresponding to, the first element comes from A, since it's the first element of our Cartesian product, the left element. So it's going to be, in this cell, we're going to have 1, 1. In this cell, we're going to have 1, 3. This is going to have 1, 9. This is going to have 1, 11. So we have 1, 1, 1, 3, 1, 9, and 1, 11. And down here, similarly, we have 3, 1, 3, 3, 3, 9, and 3, 11. So let's write that set. So we have the ordered pairs. We have 8 of them. The first one is 1, 1. So that is an element of A cross B. The elements, of course, are ordered pairs. So that's key to remember. 1, 3, 1, 9, 1, 11. Then we have 3, 1, 3, 3. I'll go down here to finish it off. 3, 9, and 3, 11. And they're all of the elements of the Cartesian product A cross B. So, similarly, figure out what B cross A is. See if you can figure out that. So pause video now, write it down. All right, so let's do B cross A. I'll do that in red here. B cross A. Well, it's not the same thing because the first element of each ordered pair needs to come from B now. So we're going to have, let's start with the first element from B, which is 1. So we'll have 1, 1, and 1, 3. Then we'll have 3, 1, 3, 3. Then we'll have 9, 1, 9, 3. And we'll have 11, 1, 11, 3. So let's just write them down. 1, 1, 1, 3. That's all of the elements that have 1 as the first entry in our ordered pair. Okay, let's do the ones with 3. So 3, 1, 3, 3. Then 9, 1, 9, 3. And then 11, 1, 11, 3. You can even think of it, if you like, as just taking each of these and swapping where the elements are. Let's look at some more about this. We'll do another example that proves a bit about these. Okay. So, let's say we have 4 sets that are subsets of some universal set U. And let's say they're indeed non-empty, just to make our life a little bit easier. This would still work if they were empty, but let's just say A, B, C, and D are non-empty. So we know that A is a subset of C, B is a subset of D, and we want to show that A cross B is a subset of C cross D. So let's prove this. We're going to do just a direct proof. Again, the reason I like a direct proof here is because we're saying things about the fundamental parts, and here we're kind of combining those parts. So it's easier to combine than it is to disassemble a lot of the times. So let's assume that A is a subset of C and B is a subset of D. So I know all elements of A are elements of C and all elements of B are elements of D. Okay, great. So now we want to show that the Cartesian product A cross B is a subset of C cross D. So what we're going to do is we're going to take an element in A cross B and show that it's in C cross D. Okay. So let's let XY, that'll be our element. Let's let that be an element of A cross B. Well, what does this mean? Then, well, must mean that X is an element of A and y is an element of B. Because that's the definition of a Cartesian product. These elements here, each entry comes from the corresponding set. So x is an element of A, y is an element of B. That's what it means to be in this Cartesian product. Okay. But we know since A is a subset of C, well, we can say that all elements of A are also elements of C. We know that thus x is an element of C. We know x is an element of A is a subset of C, so x must be an element of C. That's what it means to be a subset. And similarly, via the same reason, we know that y is an element of D. Since B is a subset of D, y is an element of B, so y must be an element of D as well. So what does that mean? So x is an element of C, and y is an element of D. Thus, by the definition of Cartesian product, we know that this element x, y, well, it's an ordered pair with one element from C and one element from D, so it has to be a member of, I have it the other way around, sorry. It has to be a member of the Cartesian product C cross D, or C times D. And that's it. We started with our assumptions that A was a subset of C, B is a subset of D. We know we wanted to show that A cross B is a subset of C cross D. So we pick an element in A cross B, and we use our assumptions to show that it's also in C cross D. So that means that A cross B must be a subset of C cross D, since this was an arbitrary element. This argument would work with absolutely any element you picked from A cross B. And we are done.